is our nucleic acids. And our nucleic acids are one of my favorite biomolecules. If I have a favorite biomolecule, protein. I don't know. If you had a favorite biomolecule, what's up, YouTube, and welcome back to my channel. With TK, and we're back with another video. Today we're going to be covering a new series. We're going to be jumping into our Central Dogma series, aka all things DNA, RNA, transport. We'll be hitting all of that fun stuff. Super excited. There was a poll on my Instagram for this one, so if you're not following me on Instagram, make sure you go to my Instagram, which I will link down in the description box, so you can be a part of every poll that we do, so you can have an input on the information that we are covering. So with that being said, make sure you go ahead and like the video, make sure you subscribe to the channel, make sure you hit that post notification bell so you don't miss an upload. Make sure you share this video to one of your friends so they can come over and spill the bottle tea with us too. So, like I said in the beginning, today we're going to be covering a new series. This series is all things Central Dogma, DNA, RNA, all that stuff related. But before we hop into the meat and butter of that stuff, we have to start with the basics. We're going all the way back. So let me run and get my sage because we got to cleanse. We can't do this without the mental reset. Hold up. All right, y'all. I'm sorry. I'm all making different. We got a new series and I'm forgetting how we do things. All right. We'll burn the sage. We're going to take 3 deep, mindful breaths, okay? So we can reset our minds for this content. Intentions to do what we need to do for today. Let's go ahead and get this kettle hot. So like I said, today we're going to be covering the basics. We're going back to the basics and hitting the biomolecules, the four major biomolecules in the body that we have, because that is the basis of where all things start. So I want to make sure I hit that, even though I already covered the bone lecture. Which, if you're interested in the bone series, I'll link it up in the cards. Make sure you get into that, learning all things bone physiology related, all things bone function, and all that fun stuff. The first thing we're going to go over are the 4 major biomolecules. That's the major vocab for this. You got the lipid, the carb, or the carbohydrate, the protein, and the nucleic acid. Those are the 4 major molecules that we're going to be going over today. Those 4 major molecules each have a structure. They have a type of bond that they hold to hold them all together. And then we're going to talk about what the monomer for all of those look like. So first, before we get into it, I want to make sure you guys know what a monomer is. A monomer is just a single unit of that particular thing. So if we had 1 carb, what would it be called? If we had one and it wasn't linked to another one. If we had 1 nucleic acid, what would it be called? That type of thing. Or 1 unit of it, what would it be called? So we're first going to start off with the carbs. A carbohydrate, or a simple sugar, is something you can also call it, or a complex sugar, are also carbohydrates. So it's just sugar. It's just the different sugars that you take in, and it's not literally sugar, like table sugar all the time. It's anything that when you break it down, it breaks down into a sugar. So when you eat wheat, bread and stuff like that, pasta, potatoes, all of those things break down into a carbohydrate. That's why, and fruit and things like that. people don't really realize that, yes, we call it in our community, in the Black community specifically, we typically call it the sugar. So we associate it with eating sweet things, but that's not what it is. That's not what it's associated with. We are calling it the right thing because it's associated with sugar, but it's because everything breaks down into sugar. So it's not just the fact that you're drinking soda all day and you're eating candy all day. It's the fact that everything we eat is loaded with carbs. We eat a lot of carbs on the plate. When you go home, think about it. We had a cookout, right? Everybody love a good cookout. Love it. But think about what we eat. You have potato salad, mac and cheese, rice, or a Thanksgiving dinner, dressing with all of those same things I just named. We have, and then we'll still have some vegetables on the plate. Like we'll have collard greens and broccoli, carrots, but all of those things are still starch. Majority of the things that we put on the plate that we love to eat are carbs. So that's why it's about balance and making sure that you don't just eat carbs all the time. And in our community, it's very common because it's easy. They're easy things to fill us with, but sometimes it can come to bite us because the things that are easy to fill us with and cheap to use for us to get to aren't always the best things for us. With all those things, those people that end up with diabetes will drink sodas and eat a lot of candy, eat a lot of junk food and stuff like that. But it's combined with the fact that they also, in their everyday meals, we eat a lot of starch generally. Well, we eat a lot of carbs generally because it's a good source of nutrients for us to eat. And I'm not saying that you shouldn't eat those things, but that's why when you add on all the junk food on top of eating the starches that we typically eat in our meals every day, is so bad. And I'll not get into portion control because we are very bad as a community with portion control, which is the other reason why we have these problems. But that's a conversation for another day. So the formula for sugar is H2NO-N. The N's represent any number, and you just make sure that the H is always 2 times what the C and the O are. So that tells you that when you look on the periodic table, that tells you that a carbohydrate is made up of a carbon, a hydrogen, and an oxygen. Which makes the basic formula, which is CnH2nOn, we have is a simple sugar. The next thing is that the monomer, or the single unit, is called a monosaccharide. So a monosaccharide would be just like that simple sugar I explained to you. That's a monosaccharide, because it's just one of those. If you put 2 of them together, that would be what we would call a disaccharide. It's 2. If you put any more than 2 together, that's what you call a polysaccharide. So polysaccharides are also where our starches are classified, because they are bigger than just that one structure. So, but we call those complex sugars. There are a lot of different structures that carbohydrates can have. You can have a carbohydrate that's just linear, or all the carbs are side by side by side, all the C's are side by side by side. Or you can have one that is in a ring shape, and those can have 5 carbons, 6 carbons, 7 carbons. That's why you would call it a pentose sugar, or a hexose sugar, or something like that, based upon how many carbons it has. But yeah, so that is the monomer of the carbohydrate. It is the monosaccharide, and then you have the polysaccharide when you put multiple monosaccharides together. The major function of the carb is energy. This is the energy source that we use for everything. So in our next video, we'll be talking about the general uses of the cell. And the carbohydrate is broken down in the mitochondria, which a lot of people refer to as the powerhouse of the cell. So we eat the food, and we break it down in the stomach and all those different places, and then once it gets to the digestive tract, that's where mitochondria and those cells start doing its job of extracting a lot of that energy so that we can use it, so we can move and think and operate as people. So that's the major thing with the carb. The carb is the energy source. The next biomolecule that we're going to talk about is the lipid. So the lipid is basically what we refer to as fat. So there are two major types of fats that we have. We have saturated fats and unsaturated fats. And that's the saturation is based upon how many hydrogens the carbon has. A fully saturated carbon is a carbon that has all single bonds on it, meaning that it has 4 different elements. Well, not 4 different elements, but it has 4 elements on each side of it. Each carbon has 4 elements on each side. That's what that means. It's fully saturated. It doesn't have any double bonds, and there are no free electrons. The carbon is fully sharing with different. It is fully sharing with different elements, and it is happy. Fully saturated. And these are your and the saturated fats are your butters. It's like when you go to school, when you go get a butter or lard or something like that, that's a saturated fat. Unsaturated fats are your oils, and they're unsaturated and liquid at room temperature. So your butters are solid at room temperature. Your oils are liquid and are unsaturated fats, and that's because they have double bonds. So these double bonds are in between the carbons, and wherever there aren't, and then the hydrogens just fill in the gaps where they can. Because not at that point, once you have double bonds, the carbon isn't going to have hydrogens all around it and be fully saturated. So that's what that means, is that it's basically double bonds in oils versus not double bonds in butters or solids. That's the basic categories in the lipid. The monomer in a lipid is basically a glycerol backbone and a fatty acid. So you put those two things together and they come together by way of an ester bond. And that is the monomer for a fatty acid. All fatty acids, not all fatty acids. That is the monomer for a lipid. All lipids look like that. They're going to have a fatty acid tail and a glycerol backbone. They'll be made differently and they'll have other things attached possibly. And I'll talk about some examples of that in a minute. But for the most part, there's always going to be a glycerol backbone and a fatty acid tail somewhere in the lipid. So, the functions of the lipid, there are 3 major functions of the lipid. There's the protection function, which is what you typically think of, what I typically think of when I think of like on our bodies. When you have this fat, what we call fat on our bodies, this is adipose tissue made up of a bunch of lipids. That adipose tissue is protecting all of your organs that are behind the fat. So when your body is storing all of the extra fat from the food that you're eating, because when you eat carbs, when you have too much of it and you don't need to continue to break it down because you're utilizing it in some way because you worked out or you work really hard at work or whatever the case may be. If you're no longer using the carbs, they are eventually stored as fat. And this is typically where that fat goes in places like your stomach to protect the organs that are there. And to also keep you insulated, but to protect the organs that are there. The next major function of the lipid is structure. So when I think of the structure of a lipid, I think of the phospholipid. A structural function, I think of the phospholipid. The phospholipid is what makes up the cell membrane of the cell that we'll be talking about in the next video. So the cell membrane is responsible for letting things in or out, and that's because of the way that the phospholipid is set up. A phospholipid has a hydrophilic head and hydrophobic tails, because the tail does not like water. It's not a fan of water. So it goes on the inside, and it's a bilayer when you talk about the cell membrane. So it's one set of phospholipids on this side, one set of phospholipids on this side, and they're back to back. So the tails of the phospholipids are in the middle, making a completely hydrophobic or water-hating area, an area that does not let water in. The heads are hydrophilic, so they love water. So they're going to be on the outside because majority of our bodies are made up of water. So for that cell to survive, it has to have something on the outside that loves water. So the hydrophilic heads sit on the outside and they sit on the inside because the cytoplasm is also mainly water. So that's why the hydrophobic or water-hating tails sit in the middle, and the hydrophilic or water-loving heads sit on the outside. The bilayer isn't going to let a lot of things in. But just know that the way that the phospholipid is set up is what allows for the membrane to do what it does. So the phospholipid type of lipid that plays a major role with the cell membrane, and really the membrane of pretty much every organelle. Pretty much every organelle is made up by it has a phospholipid bilayer. So, and then the last major function that I can think of a lipid is storage, and that's where what I was talking about when I was talking about triglycerides. And your adipose tissue is that long-term stuff that sits here, but you initially store your carbs as triglycerides for kind of almost what you think of as immediate storage. Like if you needed something, like when you start getting hungry throughout the day, your triglycerides are going to be the first things that you start breaking down so that you can have energy to keep going. So that's kind of like the three major functions of the lipid and how the lipid basically works. And there are other lipids out there, but those are just some of the major ones that I wanted to hit on. So I'm not going to go into a tremendous amount of detail about nucleic acids and proteins because we're going to be covering them a lot in the next few series. But I'm going to go over some basics so that you can have a good idea of what their monomers look like and how their basic structure looks, so that when we're moving forward, you have a good foundation. So we're first going to start with the protein. So the protein, its monomer is called an amino acid. And the amino acid is made up of, there's three major groups that I like to think of in an amino acid. There's an amine group, a carboxyl group, and the R group. And it has a backbone. The backbone is made up of a nitrogen and two carbons. The only thing that changes from amino acid to amino acid is the R group. It's the only thing that changes. Nothing else changes. So when we put two amino acids together, we make a peptide. That peptide is held together by something that is called a peptide bond. The peptide bond happens between the amine group of one amino acid and the carboxy group of the next amino acid. So when you put the amine group of one and the carboxy group of the other together, how you make the peptide bond is a water basically is formed. That water comes from the oxygen and the hydrogen on the carboxyl group and a hydrogen from the amine group. You pull those out and a peptide bond is formed. So yeah, that is the basics of how to what the amino acid looks like and the structure of the amino acid. The protein generally is used for the structure and the basis of everything. It's a hormone. It's receptors. They make a lot of the structure that you need, like your cytoskeleton, which we'll talk about in the next video, and those proteins that are in different protein channels, which we'll talk about when we get to transport. Proteins play a huge role in the body. It's super important, which is why protein is being pushed so heavily right now in the world of fitness and stuff like that. People drinking protein shakes like crazy, and telling you to bulk up on protein and stuff like that and cut out your carbs. But the problem with just going straight protein is that you need carbs, because carbs are your immediate energy source. It takes a lot of time to break down protein, and you don't want to break down protein super fast, because protein plays a huge role in getting muscles big and building up things. So you don't want to break down protein once it's built up something. So you don't want to have to pull from your muscles when you start getting hungry, basically. So that's why you still need carbs in your diet, so that when you start getting hungry, when you start getting tired, when you start needing an immediate energy source to get you through the day, the carbs is what your body is calling on, so that you can have something in the moment, so that you don't start pulling from the protein that you should be using to build your muscles. The other thing that people don't really realize is that your brain uses a ton of carbs throughout the day. So when you don't eat carbs, if you cut out carbs, a lot of the carbs, or if you do really, really low carbs, a lot of the carbs that you're eating, the few carbs that you're eating throughout the day, are probably just going straight to your brain. So that's probably why you're exhausted. So if you're doing a diet right now and you're exhausted, you should probably be eating some more carbs. Because carbs are the immediate energy source. Protein, if you're hungry, that's when you eat protein, because protein is very filling. So if you feel like you have high energy and you're making it through the day and everything's good, but you're hungry, find some protein or a very fibrous carb, like an apple, like, or some celery or something nice, a vegetable or a fruit, like something that's very fibrous. So yeah, so that's kind of the big thing with protein, is that it plays a huge role in everything because it helps to build everything. So you don't want to use it completely as your only fuel of energy to get you through the day, because you can't. And also your brain doesn't use protein very well for energy. It doesn't. That's when people start talking about ketosis and stuff like that, that's what they're referring to. That's what that kind of can go into. And I can go into that in depth if you would like to. If you would like me to, comment down below if you would like me to go into that. So that is pretty much all I can think of in relations to protein. Just the basic structure. Anything else I forgot, we'll talk about like the different structures that proteins go through and all that stuff when we get into transport later on in the series. But right now, that's pretty much the bare basics of what I want you to know about proteins, just to give you a quick overview. Last thing that we're going to talk about is our nucleic acids. And our nucleic acids are one of my favorite biomolecules. If I have a favorite biomolecule, protein, I don't know. If you had a favorite biomolecule, what would that be? Comment down below, what is your favorite biomolecule? Based off of the descriptions in this video, what's your favorite biomolecule? I think mine is protein. I think it is. I love what proteins do. Even though DNA is the instructions, and I'm about to get into that, and the kind of like the brains of the operation, which they are a strong second. But proteins they do so many things. They're so versatile. The DNA can send a message, and we'll talk about what that message looks like and how the message is sent in the next few videos in the series. That's what Central Dogma basically is how the DNA makes a message and then sends the message. So it's just interesting to think about it. Like, the DNA and the nucleus, it's making out all the instructions and everything you have, and then the RNA, which is also a nucleic acid, plays a role in getting that information out so that the protein can be made. It's kind of cool. So generally, the monomer for a nucleic acid is what we call a nucleotide. A nucleotide is made up of 3 major parts. It's made up of a pentose sugar, so it's made up of a carb, a phosphate group, and a nitrogenous base. So the nitrogenous bases, there are 5 different types of nitrogenous bases. There's 2 major categories of them, but there's 5 of them. So the 2 major categories are purines and pyrimidines. The purines are the larger, so they have 2 side-by-side structures. And then the pyrimidines are the smaller. They have 1 structure. So your purines are your adenine and your guanine. Your pyrimidines are your cytosine, thymine, and uracil. So how I remember that is, you look on the periodic table, the symbol for gold is Ag. So that tells me, when I see that, I think pure. I know gold is pure. And the beginning of purine is pure. So that helps me remember that purines are pure as gold. That's kind of how I remember it. So that and I know which ones go in that category. And then when I look at the pyrimidines, you put those together and it makes the word cut. Now, how these purines and pyrimidines come together is that adenines bind to thymines, guanine binds to cytosine. Uracil can replace the thymine, but that's in RNA structure. So in RNA doesn't have any thymines, it has uracil instead. That's one of the ways that you can differentiate DNA from RNA, is the fact that DNA has thymine, and RNA has uracil. And then also the fact that, see, RNA has ribose, which is a 5-carbon sugar that has oxygens on both sides of it, while DNA has deoxyribose, which is the same 5-carbon sugar, but it doesn't have oxygens on both sides. So it's basic structure things that separate DNA from RNA, and also what they do, because DNA is utilized to make RNA. You make RNA using DNA as a template. So they're very much so related, and they have to be, because they have to be able to bind together to a certain extent, so that so that the RNA can be made. And we'll talk about that in the upcoming videos. But generally, the deoxyribose versus ribose and the uracil versus the thymine are the major differences between DNA and RNA, and the fact that DNA is a double-stranded helix while RNA is a single strand. So those are some of the major differences between DNA and RNA. But when you look at DNA and RNA, like I said, the adenine is going to bind to the thymine or the uracil, depending on if it's in RNA or DNA, and the cytosine is going to bind to the guanine. Adenine and thymine are going to only bind with 2 hydrogen bonds, while guanine and cytosine bind with 3 hydrogen bonds. So the bond between the guanine and the cytosine is a lot stronger than that of a bond between the adenine and the thymine. But like I said, those are the purines and the pyrimidines, and then you have the pentose sugar, which is the deoxyribose or the ribose, and then you have a phosphate group, which is a phosphorus and 4 oxygen. Phosphate group, along with your 5-carbon sugar, is what allows for the phosphodiester bonds to be made to make the phosphate backbone. So the phosphate backbone is basically what makes up the helix. And then on the inside is where you find the nitrogenous bases, which are held together by hydrogen bonds. Another way that can help you remember which nitrogenous bases go with which is that you have to keep in mind that a purine has to be beside a pyrimidine. 2 purines cannot be hydrogen bond together, and 2 pyrimidines cannot be hydrogen bond together, because 2 pyrimidines would be too small and 2 purines would be too big. There's a certain amount of space that is in between the hydrogen helix. Only a certain amount of space, and that is perfect. Is the perfect amount of space to fit the hydrogen bonds and the space between the purine and the pyrimidine. So the purines are the same size, the pyrimidines are the same size. They're just configured slightly different ways to make them different. So that allows for them to fit into that double helix perfectly. So those are the major things I can think of with the DNA. If I miss something with the DNA or the protein, I'll bring it up in the next videos that we have coming up that will go over those things in a little bit more detail and go over where we go from here. But I just want to make sure that we started back over and got back to the basics so you guys can have a good idea of what provides our energy, what's providing the instructions for the cell, what everything in the body is made up of, and what's protecting us and holding us down. So when we start going and diving really deep into the body and really start diving deep into all the biology, because these 4 biomolecules are the basis of it all. So if you enjoyed this video, make sure you give it a huge thumbs up. Make sure you comment down below. Comment down below things that you want me to cover in the next few videos, the next series that you might want me to see. Make sure you head over to my Instagram and comment on my latest post, which biomolecule is your favorite biomolecule. And make sure you also share the video while you're on Instagram too. Just go ahead and put it on your story. You know you want to. You know you want to share the video, and you know you want to make sure you hit that subscribe button on the bottom. And make sure, and you know that you can't hit subscribe without hitting the bell, because why would you subscribe and not know when I'm uploading? What's the point? So make sure you hit both of them, okay? We'll be back though. We'll be back with the next one. And I hope you enjoyed this video. Like I always say, peace and blessings. And I hope y'all have a great day, a great week. And I hope it's full with abundance and positive vibes. I'm out of here. Peace.